their quiz at the end of class, so they definitely want to be paying attention. This is a good review for them. That's a good review for everybody. So let's talk about the order of things coming up. So we'll do our 10 practice problems a little faster than we did yesterday, probably. Then we have short notes day, lots of time to work on the homework. And once we start the homework, Chase, Lily, Haley, you guys will be taking your first trig quiz. Then on Monday, we'll do 10 more review problems at the beginning, just like we did today. And then we'll have our new notes, and then we will do a optional forgiveness retake on Monday. So you guys, we practiced yesterday, we'll practice today. If you feel like you're not getting this, like this might be the telltale moment. Like yesterday, we really did a deep dive into this, right? And let's see how you guys do with it today. If you do really well with this today, maybe you don't need to do any work on it over the weekend, okay? You just have to make a personal decision about how much work you need to put additionally into this outside of class so that you can get the perfect score that you really need, okay? So, and then we have our first test scheduled. It's not this Monday and Tuesday, it's the following Monday and Tuesday. I'm sorry to have it on a Monday. I really try hard not to have tests on Mondays. I know that's not ideal. But I kind of decided when I built some work days in that was a better trade-off to, have some work days built in. It meant a test was going to fall on a Monday. I just felt like that was still a better choice than not having work days. So that's what happened, okay? So we'll review next Thursday, Friday, test after Valentine's Day weekend, Monday, Tuesday. Okay? All right. So let's get started. Again, whether you write this or not is your business. Whether you write the ordered pair and what quadrant it's in, like I have been doing, that's your business as well. You decide. I don't care how much work you show. You decide what works for you. All right? So again, we always start with the denominator. Denominator tells me my ordered pair. Sign is the y value, remember. And then, let's see, Jocelyn. What quadrant am I in number 11? Your name's not Jocelyn. Take your headphones off. That says you're not listening. Yes, we are in the fourth quadrant. And is sign positive or negative in quadrant 4, Jocelyn? Perfect. Perfect. The speed at which we just did it, with me even reprimanding Evan, is just as fast. I know. Is just as fast as we needed to do it. Right? Denominator of 3 is 1/2. Square root of 2. Sam, what quadrant am I in? Sam Fernandez. Yep. Quadrant 4 again. And cosine is the first number. Is cosine positive or negative? Positive, right? Positive is the C. Yep. I know you know. Right? Another denominator of 3. That gets me my ordered pair, right? Lily, what quadrant? No. Remember, if the top is less than the bottom, it can't be in the bottom half. Let's not forget this, guys. On the unit circle, these are proper fractions, where the top number is less than the bottom number because you haven't reached 1 yet. We're growing. We start at 0, we get to 1 whole pie. And then in the bottom half, these are improper fractions. We subtract 1 from the denominator here. We add 1 to the denominator. And then here, it's just more than 1. Okay? So yes, it's an improper fraction. It's 3 or 4. Yes, I heard you say quadrant 3. Very good. Sorry. I'm over here. Sorry. We are in quadrant what? Sorry. Did you say? 2. Sorry, I was on the wrong problem. Quadrant 2, that's 1/2. In quadrant 2, is cosine going to be positive or negative? Remember, it's negative. Guys, remember, these letters mean where sine, cosine, and tangent are positive. Okay? So if that letter isn't there, C is not in quadrant 2. There's no C in quadrant 2, it's just an S. That means it has to be negative. So that's negative 1/2. Okay? Another denominator of 3. There's those ordered pairs. There's the ordered pair. Dan, what quadrant am I in? 3. Good. Cosine is this one. What's the sign of cosine in quadrant 3? Negative. Because only tan is positive. I didn't say tan, I said cosine. So it's negative. Okay, denominator of 6. Square root of 3 over 2, 1/2. Raja, what quadrant am I in for 15? Yep, very good. Cosine is the first number, and quadrant 2 is cosine positive or negative. Negative, because it's not an cosine is C. S is positive, so cosine has to be negative. Good job. All right. Oh, tan. I don't really. Well, it's a quadrantal. Remember, pi over 2 is at the top. 3 pi over 2 is at the bottom. Don't forget, those are the only two angles that have a denominator of 2. Angles, not trig functions, right? Those all have a denominator of 2. The two thetas that have a denominator of 2. So pi over 2 is 0, 1. And these are the only times at the 4 quadrantals that you actually have to think about tan as y over x. So this is 1 over 0, right? But don't leave it like that. That's not any credit, okay? 1 over 0 is not the answer. What would the final answer be? Undefined. You guys are making me a little worried. I'm not going to lie. Think back to when we did rational expressions way long time ago. We would have problems like we'd factor the numerator, and you'd have like something like this, and we had vertical asymptotes and holes and all kinds of stuff. We had to say what x can't be. What can x not be in this equation? 1. Why can, who said that? Because you're right. May, why can't x be 1 in this equation? Denominator would be 0, right? Think about something that should make sense to you guys. You've never been allowed to have a 0 in a denominator. You say a 0 in the denominator, you say that's not okay. And not okay in math means undefined, okay? Denominator of 4 with a tan, those are 1, right? Evan, what quadrant am I in? 17. Good. And in quadrant, nope, not quadrant, you said 2. In quadrant 2, is tan positive or negative? Evan? Nope. Well, yeah, if it's not positive, it's negative. Okay, guys, we've got to know this stuff. Got to know those signs, right? Denominator of 6 is square root of 3 over 2, 1/2. There's my ordered pair. Jackson, what quadrant am I in 18? Yes, sir. 1/2 is the y value. Is sign positive or negative in quadrant 3? Perfect. Thank you. Denominator of 3. There's my ordered pair. Juan, what quadrant am I in? 19. Sorry. That's right. Sign would be this number. In quadrant 3, are we positive or negative? Let him answer, guys. Negative, right? Good. Very good. Who wants to be picked on? Anybody want to be picked on? May, you do. What quadrant am I in? I said May. I meant Remy. Sorry. Remy, can you finish it for me? I'm sorry. Guys, I've had dull luck this week, and I'm recording, so I'm not going to say why, but it's been really bad. If I stop recording, maybe you can ask me if you care. Okay, sign is right here. Is sign going to be positive or negative in quadrant 2, Remy? Yes, positive. All right. Thank you, May. Thank you, Remy. Thank you, all of you. Some of you are getting this super fast, and I can actually see the difference between other days and today. So very good job. Keep up the practice. Some of you are still not knowing this stuff. You've got to put the practice in. You are going to get left behind your classmates. You're going to be the one struggling on the trig. You don't have to struggle. You put the work in now, then you've got it. Okay? You'll have it. Remy. So guys, get to page 51. Remy, you know how you got a perfect score on the quiz? No. Do you know how? Yeah? No. You know how you did? Like say yes. Okay. You know how you got a perfect score on the quiz, Remy? Yeah. Like now, when I ask you these, have you forgotten them? No. So that's the point I'm trying to make. Sorry, I'm not connecting on all firing on all cylinders right now. My point is, once you get it, you have it. It's just there. It's somewhere up there. You got to get it in there first, though. You cannot be lazy on this. You cannot be lazy. You have to put the work in. Especially if you've been missing class, you're at a disadvantage because we've been doing this every day. So you've got to get some time in on your own. Okay, pretty short note, actually very short notes. A lot of review again. And I think I told you yesterday we would be finally doing the phase shift, which is left or right, which is the letter C. I was wrong. It's actually Monday that we do that. Today is pretty much review stuff, okay? So just starting out with sine or cosine, we know the period is 2 pi over b. I mean, we've used that formula Monday, Tuesday, Wednesday, Thursday, now Friday. It's just not changed. It's not gone away. It's the same for sine, same for cosine. In word problems, you might hear instead of, like, it might be not be in these words, this would translate in a word problem to time over cycles. You know, in the real world, something goes through that pattern in a certain amount of time. And you always put time on top, cycles on bottom. Now, frequency is just cycles over time. These two are reciprocals of each other. Reciprocal just means flip the number. Reciprocal is just taking a number and flipping it, okay? So if you know period, then you just remember frequency is the flip of it. And when we get to this word problem here in a second, I'll explain what frequency comes from, like why we use it. It's used a lot, though, it's really only used in word problems typically, and it's lots of sciencey stuff. And I like to think of frequency as it makes more sense to state something that's happening in a word problem in terms of frequency, cycles over time, and I'll show you what I mean in a second, versus time over cycles. But just really for this class, mostly, you just have to know that it's the flip of period. Okay? So in our very first example, find the period for the 5 millionth time. I mean, how many times have we done this? And then flip it to get the frequency. Okay? So period, we know, is 2 pi over b. So there's the b. Keep, change, flip. I don't need to see the work, okay? Keep 2 pi, change multiplication to, change division to multiplication, flip that fraction. Our period is 8 pi. Think about what that means. Spread over 8 pi of the x-axis. Huge space is 5 points. So your graph going to be, if we had a graph, it would be really, really, really spread out. That's a really long period. And then the frequency would just be 1 over 8 pi. That's it. Just flip it. Okay, same thing. Period is 2 pi divided by b. Just simplifying a fraction. The pi's would cancel. And 2 over 48 is 1 over 24. So the frequency is 24 over 1, or you might just write 24. Either one is really okay. In a word problem, it kind of makes more sense to leave the 1 there, and I'll show you that in this problem, okay? But either one is fine. All right, so easy math, and I'm pretty sure in the word problem, on the test, and we'll see the review soon, it's really more multiple choice. We have to kind of just know that it's the reciprocal of it. But let's take a look at this word problem. My sciencey people really get into a lot of the word problems in the trig section. If anybody's in physics or into physics, I have a few students, Sam, your brother's one of them, like into the sciencey side of math, you know. It just, his face lights up because it's like home for him. He's familiar with, like, I love the math part. He loves the science part. You know, we all have our thing. Okay, so anyway, so let me read. This is, word problems, yuck, right? We don't love word problems. But let's break it down. A mass on a spring oscillates back and forth and completes one cycle in 20.25 seconds. That's probably important. I hear the word second and cycle. I'm going to underline that. Let me just go back to the word oscillates. Like an oscillating fan, like when a fan is like rotating back and forth, that's sine or cosine. It's following, it's just repeating this motion over and over again. And think about a spring. It would just go up and down and up and down, okay? So it's repeating that motion. Its maximum displacement, there's a number that's probably important, right? So I'm underlining it. Maximum displacement, well, even if you don't know what displacement means, and I'll explain it, the word maximum should kind of be like, wait, I know maximum and everything else is the highest y value. So, and that's what this is. This is going to translate into our amplitude, by the way. I'm just going to go ahead and write it. Amplitude is going to be 6. And displacement is like how far from its original starting place it travels. So at max, it's going to go 6 centimeters from where it started, is what it's saying. So that's, translate that to amplitude, right? We're going to write an equation that models this motion if the spring is released from the maximum height. Now, when I read this word problem the first time, I didn't realize how important that little phrase is, and we'll come back to why when we get to when it's important. And we're going to find the frequency. So really 2 parts to this. We want the equation and the frequency. Okay, so let's back up. For any equation, we're going to need the A and the B. We got the A, we need the B. So B would be, we would get from our period. And we just learned that a period is 2 pi over B. We knew that. But we can translate that in word problems to time over cycles. So my period is 0.25 time, right, seconds in 1 cycle. Well, let's simplify that. Let's put that in a little bit more easy math to work with. 0.25 over 1 is 0.25, but fractions really make more sense in these problems, so let's just make it 1/4. So my period is 1 over 4. How much time it takes to go through 1 cycle? 1/4 of a second. Well, now we can do the frequency. Frequency would just be 4 over 1. So it takes 1/4 of a second to complete 1 cycle, or it makes more sense, like if we were having a conversation, if we were 2 scientists and we're talking about it, it really makes more sense to say 4 cycles in 1 second. It just makes a little bit more sense, and that's where frequency comes from. I don't want you guys to stress about it, overthink it too much. It's the reciprocal of that, and it just kind of makes more sense in describing something in a word problem. That's what I think where it comes from. Okay, but we still need B, guys. We still don't have B. But now we have important information. Period is 1/4, because B is just 2 pi divided by the period. Remember, that formula is the same if you want period or B. 2 pi divided by what you have gets you what you need. 2 pi always on top. Keep change flip, we get 8 pi. Well, now I have my A and my B. I'm ready to write my equation. But I have a choice of sine or cosine here. And I got to go back into this problem and figure out, is there some clue, yes, as to whether this is going to be sine or cosine. So if so I want you guys to really think about this. Don't just guess, because it's a 50-50 chance, right? Sine or cosine. Think about it for a second in your own little brain. Not little brain, I didn't mean it like that. If I'm releasing from maximum height, that means I'm starting here, right? Think about pulling a spring up, and then you let it go. So it starts at 0 seconds at the top. Which graph, sine or cosine, starts up? Cosine. So let's review that. Sine is middle, up, middle, down, middle. We have to know it. And if there's a flip, it's still middle, then it goes down. Middle, up, middle. So sine is middle, up, middle, down, middle. With a flip, it's middle, down, middle, up, middle. In a flip, your ups and downs just change places. Cosine is up, middle, down, middle, up. If there's a flip, down, middle, up, middle, down. Okay, back to the problem. Let's write the answer. 6. We decided it's cosine. 8 pi is our B. And then use any variable you want. X, T, theta, any letter you want, doesn't matter. Okay. There's my frequency. There's my equation. All right, one last example. And this is just, Jean Adams, this lady that makes this stuff. Her notes are a little long. Her homework assignments are sometimes a little long. That's why I do a lot of skipping. But what I do like about her notes that some of the other curriculum writers don't do is she does a lot of circling back and reviewing. And here we are again talking about concavity, increasing, decreasing, points of inflection. These properties of all different functions have come up, it's like the 5th time we've talked about them. That must mean they're really, really important things you have to know that'll be on the AP exam, and they will, okay? So it's nice that we keep getting to review them with different graphs. Here we go. Consider the first period of each of the graphs. So what they're saying is, here's a bunch of, curvy graphs. Let's just consider the first period and answer 4 questions about it. So and we're just going to do one of these. Let's look at our first graph. How do I find the first period? Well, you can really start anywhere. We talked about this yesterday. Starting at 0 is always easiest. So I'm just going to start here, and I'm going to go out 5 points. So this would be middle, up, middle, down, middle, right? There's my first period is from here to here. So when I'm answering these questions, I'm just looking at those 5 points. We should know it keeps going on and on forever in both directions, but we would spend the rest of our lives answering these questions if we had to answer for the whole graph. Just these 5 points. Okay, find the 5 key points for one period. Well, we kind of just did that, right? Middle, up, middle, down, middle. There they are. And so let's name them now. So just name these 5 ordered pairs, X and Y. I just saw an email. Wednesday, March 5th is the in-school SAT. All 11th graders will be taking a college reportable SAT. Specific 12th graders will be taking a non-college reportable SAT. This is students that have not passed the Algebra 1 EOC maybe, or the FSA, or what is the English one, ELA? Is that what it's called in English? Fast? Is that what it is? Okay. That. And then specific 12th graders will be taking a college reportable SAT. Students currently enrolled in or have completed the academic requirements to qualify for Bright Futures, currently meets Bright Futures GPA requirements, and their highest SAT scores within 150 points of meeting the Bright Futures SAT score requirement. This is a new district initiative, and they specified the criteria for this. I don't know if that makes any sense to you guys. Does that make any sense? 11th graders, you're all taking it. 12th graders, you only are taking it if you didn't pass something, one of those things, or if you're a Bright Futures person or really close to being Bright Futures. We're trying to help you get that SAT score you need for Bright Futures. I guess. I don't know. Okay, let's go on now. Mr. Bernstein is in charge of that, so if you see him out there at lunch or something, he's the guy to ask. All right, B, identify where the function is concave up and concave down. Guys, with concavity, you must use parentheses. It's non-negotiable, and we only use the x-axis to name that. So looking at our 5 points, I think we're pretty good on concavity. I think you guys would agree that this is concave up. That's from pi over 3 to 2 pi over 3 in parentheses. Right? That's concave up. And then we have this concave down right here, which is 0 to pi over 3. So only the x-axis, this to this, right? Good. See, increasing and decreasing, I'll explain that again. Just so you know, increasing and decreasing can be brackets or parentheses. You choose, doesn't matter. Full credit on both. Increasing means literally where's the graph going up, like has a positive slope, not whether the numbers are positive or negative, that has nothing to do with it. Increasing, decreasing. So let's start with increasing. And the word interval we know means x-axis. So from here to here, we're going up, right? That would have a positive slope. So that's from 0 to pi over 6, brackets or parentheses. And let's just make sure there's not another one. Oh wait, there is, right here to here. This is also increasing. We call that a positive slope right there. That is pi over 2 to 2 pi over 3. And look, we're decreasing. That whole section is decreasing. From there to there, we're going down. All right? So that's pi over 6 all the way to pi over 2. Okay? If you're having trouble with any of these, when I'm done, call me over and I can help you one-on-one. Okay? And last one, points of inflection. Points are ordered pairs. Points, okay, x, y, x, y, x, y. And points of inflection are where your concavity changes. So this is, right here, this is concave down. And then so this whole thing, is concave down. So this would be a point of inflection because it changes. Well, and it's about to change after this too, right? After this point, it changes. This point is still on our 5 points. But guess what? So is this one. Because before this one, there would have been concave up. And right here is where it changed to concave down. So we have 3 points of inflection. So you just name them 0, 0. I was trying to think about this. It might be always at your midline. I hate saying always. I'm going to check some graphs and look back at it, but I almost feel like on these graphs, your points of inflection are right on your midline. I think that is what happens, but I'll double check that and get back to you. Okay? So that's it for the notes. Let me give you the homework, and I'm going to do, there's 2 types of problems in your 10 problems. I'm going to do one of each with you just so you feel more confident. So one of the things you have to do, and you've been doing it this week and I've had a few questions on it, is sometimes you have to make a graph where the x-axis is labeled for you. So I want to talk about that really quick. I'll put this back up in a second. Let me just show you something really quick, okay? Let's do this. If I have an x-axis with a whole, I'm just making a whole bunch of lines, and I have a period of, say, 4 pi, and I have to label it myself, here's what you need to know. There's 5 points, right? There's 5 key points in all these graphs, but you only need 4 sections of the x-axis. Because the first point is here, and then you just make 2, 3, 4. You can break your x-axis up however you want. Do you want to go out 2 for each of these points? Do you want to go out 3? So I could make this one of them, let me use this one, and this one. So if I use here, so 1, 2, 3, 4, 5, those could be my 5 places I'm going to put my points. So from 0 to 4 pi. How do I label all the ones in between? Well, you can divide 4 pi by 4. There's 4 sections, right? This one's 0, so this would be 1 pi, 2 pi, 3 pi. If it's not that easy of a math, find the midpoint between 0 and 4 pi. That would give you this one, and then the midpoint between these two would be this one, and the midpoint between these two would be this one. Okay, so just remember, anytime you're making the x-axis your own, you have to label it yourself. You can separate them by 2, 1, 2, 3, 5, 5, doesn't matter, and then label from there. So that's what I'm going to show you in our very first problem here, number 1. So C18, are we ready to go? Where's my homework? So let's do number 1 together, okay? So look, just call out, guys, what is the amplitude on number 1? I didn't hear a negative. Good. But we know there is a negative in front of it, so it means a flip. The period would be 2 pi divided by b, right? B would be 1. And by the way, guys, there's a theta there. What does that mean? Theta is the same as x, okay? It's just the Greek alphabet. Who cares? Let them use their letters if they want to. Sometimes we use z or t or x or y. Sometimes we use theta or alpha or gamma or beta. It's just a variable, okay? Theta is s. I'm not sure. Anyway, in front of that, my b value would be 1. Okay, so 2 pi divided by 1 is just 2 pi. The max, min, and POIs are easier once the graph is done. So I'm going to first separate my x-axis into 4 sections. You decide how far apart you want them. Just make it the same. Like this time I might do 3. So I'll make there's going to be one of my labels. 1, 2, there, 1, 2, 1, 2, 3, and then 1, 2, 3. So I'm going to use from here to here as my period, 0 to 2 pi. So anytime your period is 2 pi, your x-axis is marked by your quadrantals. So it's kind of nice. Just go through your quadrantals. 0 is on the y-axis, and then we have pi over 2, pi, 3 pi over 2. Okay, we're ready to graph. Amplitude of 4 with a flip on cosine. So cosine is normally up, middle, down, middle, up. With a flip, we start down, right? Down, middle, up, middle, down. There she is. So once I have the graph, it's really easy to find my maximum point. There she is. Pi 4. It's a point. Pi 4. And I have two minimums, right? 0, negative 4, and 2 pi, negative 4. The two lowest points. And look for points of inflection. This would have been still concave up right here, right? That's concave up. So here's where we change to concave. It's hard to see it, but it's that midline. And then here we change again. So it's just these two. Okay. So those would be your points of inflection. So pi over 2, 0 points, ordered pair, x, y, and then 3 pi over 2, 0. Okay? So don't try to do max, min, or POIs without the graph. Do the graph, then it's easy to find them on there. Okay? Hold off on going on to number 2 because I want to do number 5 with you, the second set of problems, just because I'm going to get questions. It just makes it so much easier to do the first one with you. We've done these a million times. What they're asking us to do here is describe the relationship between f of x and g of x. How did f of x change by throwing these numbers in? So just knowing what that negative does to the graph. What does that 1/2 do? And then include the rule. Don't worry about the calculator. So think about what's been added on. Here's sine x. So what does that negative do and what does that 1/2 do? And there's lots of ways that you can say this. There's not just one way, but I want you to use your varsity math language, your AP math language. Like, don't say flip over the x-axis. Let's say reflex over the x-axis. That's what this negative does, right? Our up, middle, down becomes down, middle, up. That's a flip over the x-axis. So reflect over x-axis. And then that 1/2, which is your amplitude, it's a vertical dilation. Stretch or shrink, but you can just use the word dilation. We've done this so many times. Vertical dilation by factor of 1/2. So that negative and that 1/2, that's what happened. And then the rule, remember, f of x is xy. All your points are xy. What did that negative and that 1/2 affect? Remember, if it's not in the parentheses with the x, it changed the y. There's nothing going on with our x, so nothing happens on any of the x values. The y values get multiplied by negative 1/2. Okay? So that's what those problems are. In your own words, I'll put the key up. You can see my version of it. If you have a question, if your wording is okay, just ask me and I'll tell you. Right? There's more than one way of saying all these. The order of them doesn't matter, any of that stuff. All right? So my 3 quizzers, if you wouldn't mind, if you have a phone and you can put a 3-minute timer on it, I would ask you guys to do that, please. Lily, Haley, Chase. Grab your phone and can you put a 3-minute timer on it? It's just easier if you guys have your own individual timer and you're not trying to do it.